Okay, so let's talk Apache Spark. What if I told you that, well, just knowing the basics isn't really cutting it anymore? We're
Yeah.
seeing this shift, right?
Yeah.
From just being competent with Spark to really mastering it. The best data folks out there, they're not just, running jobs. They're turning data into a real competitive edge.
Yeah.
It's about unlocking Spark's, well, it's full power.
That's spot on. I mean, Spark is everywhere. It's become the engine behind, gosh, countless innovations. Big data analytics, real-time AI, you name it, Spark's probably involved. People trust it globally. Speed, scale, flexibility, has it all. But data's getting so much more complex, right? And there's just so much more of it. So yeah, just knowing Spark, it's often not enough for companies trying to lead the pack.
Right. So the stakes are getting higher. It's not just about ticking a box anymore. Companies are drowning in data.
Yeah.
And if they can't use it well,
Hmm.
they're falling behind. And for the individual, the data scientists, the engineers, what happens if you don't have that deeper knowledge?
Exactly. That complexity means organizations need, well, more than just the basics. They need that deep, advanced expertise to really get results. Without it, you see cloud costs ballooning because things aren't efficient. Decision-making gets sluggish because pipelines are too slow. AI models, they might underperform because the data feeding them isn't quite right. For a data professional, getting this advanced skill set, it's a huge career booster. It really makes you stand out. Opens up some serious doors.
Okay, let's dig into that. Mastery. What does that actually look like day to day? What's the real difference, the tangible benefit a Spark Master brings that someone just starting out can't? Like, take a common problem. A Spark job takes hours to run. Nobody knows why. How does a master handle that differently?
Perfect example. For the business leaders, the impact is immediate. It hits the bottom line. First off, much faster data processing. A beginner might just, write a simple join. A master, they're thinking about partitioning, how to avoid those costly data shuffles across the network. They understand data locality. They might use a broadcast join if one data set is small, or carefully repartition to handle data skew, that kind of thing. And that optimization, it can take a job from hours down to maybe 15 minutes. That means faster decisions, faster reactions.
Wow, okay. So it's not just throwing more servers at it. It's smarter work, not harder work. And that must lead straight to cost savings, too.
Absolutely. That's the second big win. Lower cloud costs.
Yeah.
Significantly lower. A master prevents waste. They know how to size the compute resources just right for the job. They think about data dermats, like using Parquet efficiently, managing memory, garbage collection, all that stuff. In streaming, they know how to use checkpointing smartly so you're not constantly recomputing everything. It stops you from just burning money on idle or oversized clusters. It's intelligent scaling.
And the third piece you mentioned, the AI models. How does Spark Mastery help there?
Right, building smarter AI. A master can tackle those massive, messy data sets you need for really good models. They build optimized pipelines, they ensure data quality, they handle complex feature engineering efficiently. Basically, your AI gets better, more accurate insights because the data foundation is solid. These pros build robust, scalable pipelines. We're talking petabytes processed in minutes, not hours.
That's a crucial difference. It's about doing it right, efficiently, reliably. So what are the specific tools or deeper techniques in this advanced Spark toolkit? What lets them build these systems and fix those slow jobs?
Yeah, this is where it gets really interesting. It's not just the basic commands. Masters use tools like Spark structured streaming, but they use it for complex stuff. Stateful operations, windowed aggregations, handling late data correctly with watermarking. Think real-time fraud detection or IoT analytics where you can't miss things. They build fault-tolerant, end-to-end streaming apps.
Right, so mission-critical stuff that needs to be always on, always accurate. What else is in the toolkit?
MLlib is another big one, not just running a basic model. A master uses it for distributed feature engineering at scale, complex model tuning across the cluster, and crucially, integrating it all with MLOps machine learning operations, deploying, monitoring, versioning, retraining, the whole life cycle. And then there's graph frames for finding hidden connections, like uncovering fraud rings, optimizing supply chains, maybe spotting cyber attacks by looking at network patterns. It's about seeing the structure within the data.
Okay, powerful tools.
Yeah.
But using them efficiently without breaking the bank, how do they ensure that happens?
That's the absolute core of mastery, performance optimization. They're not just users, they're tuners. They live in the Spark UI, diagnosing bottlenecks. They understand the DAGs, those directed acyclic graphs to see where shuffles or slow stages are happening. They know how Spark's Catalyst Optimizer works, and sometimes how to, let's say, nudge it in the right direction with hints or restructuring queries, especially with tricky data. It's about knowing why it's slow and how to fix it fundamentally.
So for a company, Getting these skills feels essential. Do you build it slowly in-house, or is it faster to bring in experts?
Often, for speed, bringing in external consultants or making very targeted hires is the way to go. Building that deep expertise internally takes time, and you might make costly mistakes along the way. An expert can really accelerate your projects, help you skip the common pitfalls, and get that competitive edge much faster. It's like a jump start.
Okay, let's flip it now. For the individual data pros listening, what does moving into this advanced Spark territory mean for your skills, your day-to-day?
Yeah, for individuals, it's about going way beyond just running scripts someone else wrote. It means really truly understanding Spark's guts, its internals. And this isn't just theory, it's super practical. Understanding the DAG lets you see why a job is slow. Are there too many shuffles,
Yeah.
inefficient stages? You can see if data is staying put or being moved around unnecessarily. That directly tells you where the performance issues are.
Like having X-ray vision into the engine, you can pinpoint the problem.
Exactly. And that vision extends to the Catalyst Optimizer. It's smart, but it has limits. A master knows, for instance, that custom functions, UDFs, can sometimes bypass optimizations. So they might rewrite things using built-in functions, or they'll use specific join strategies or hints to guide the optimizer when the query is really complex or the data is skewed. Turns a slow query into a fast one. And then there's knowing how Spark shuffles data, how it stores it. Uncontrolled shuffles. That's often the killer for performance. Understanding partitioning, how data spills to disk, why formats like Parquet matter, knowing when to cache data to avoid recomputing it. This stuff is gold for debugging, optimizing, and building apps that don't fall over with real-world data.
Yeah, that definitely sounds like the kind of deep knowledge that opens up the really interesting high-impact roles.
It absolutely does. The skills you build are things like creating complex real-time pipelines that handle errors gracefully, automating deployments, integrating smoothly with ML and MLOps tools. This is the stuff that gets you noticed. It leads to roles like machine learning engineer, principal data scientist, senior architect roles, the jobs shaping the future of data.
Okay, so let's make this really concrete for everyone listening. How can you apply these ideas right now? What are the takeaways?
Well, if you're leading a business or a data team, take a hard look. Does your team really have the advanced Spark skills you need for your AI and analytics ambitions? Are slow jobs or high cloud bills holding you back? Maybe investing in expert help or targeted upskilling is what you need to break through. It could be the key to leading your market.
And for the data professionals themselves,
Yeah.
the ones wanting to level up.
For you, it's all about hands-on experience. Seriously, don't just read about it. Build things. Find a slow Spark job you know about. Dig into the Spark UI. Figure out why it's slow. Data skew, shuffles, bad joins. Then try to fix it using these advanced techniques. Build a streaming pipeline, even a simple one. Learn about watermarking. Look into certifications, sure, they can help validate skills, but more importantly, contribute to open source or apply this stuff to solve a real problem at work. That's the portfolio that gets you hired and moves your career forward.
Yeah, it really feels like the future belongs to those who can turn all this data into actual intelligence. And Spark, well, it's the engine making that possible at scale.
It really is. And it's a journey, right? Always learning, always applying. The real power isn't just running the code, it's understanding that whole dance between data, compute, and optimization. Keep being curious, keep experimenting.
Couldn't agree more. We hope this deep dive gave you some things to think about, maybe your next big step. Until next time, stay curious and keep innovating.